Hi, Algebra to Honor students. All right, so in today's video, we are going to talk about complex numbers, which means we have to know a little bit of I. So we do know a little bit about I, my bad. We do know what complex numbers are already because we define them in Unit 1. Complex numbers are any number that takes on the form a plus bi, where we are made up of a real part and an imaginary part. All right, so we're going to do operations on said complex numbers, but before we do that, we have to understand a little bit more about how I works and what the cycles of I are. So we know that I is considered to be the square root of -1. So if we take I and we square it, then that would be us squaring the square root of -1, which means we just get -1. If we take I and we cube it, that's like us taking I squared times I. So that's saying -1 I. If we take I and raise it to the 4th power, that's equivalent to us saying take I squared and multiply it by I squared. So that would just be -1 times -1, which is +1. If we take I and raise it to the 5th power, let's be creative with this. I'm going to make this I cubed multiplied by I squared, just for fun, right? Okay, so that's -I times -1, which is I. All right, what about I to the 6th power? I to the 6th power, we can write as I to the 4th times I squared. Okay, I to the 4th is 1. I squared is -1, so this is just -1 again. Okay, so I'm going to do a little summary here, and let's see if we can see what's happening. So I, we write as I. We know that that is the square root of -1, but we won't write it as the square root of -1. I squared, we've determined, is -1. I cubed, we've determined, is -I. I to the 4th is 1. I to the 5th is I. I to the 6th is -1. I'm going to let you take a guess what you think I to the 7th is. And if you are guessing -I without doing any work, you are correct. You're starting to see the pattern here. So we have what we consider to be 4 cycles of I. And so we can do I to any power using those cycles of I. So I could say like, hey, let's do I to the 57th power, for example. Knowing that I to the 57th power is going to be equal to I to whatever the remainder of 57 is when I divide 57 by 4. For example, I to the 5th power, if I divide 5 by 4, you should get a remainder of 1. And so this end up I to the 5th is the same as I to the 1st power. If you take I to the 6th power, if you take 6 and divide it by 4, you would get a remainder of 2. And that gave you the same answer as I squared, conveniently. 7 divided by 4, you should get a remainder of 3. That gave you the same thing as I cubed, and so on and so forth. So let's try this with 57. If I take 57 and I divide it by 4, 4 goes into 5 one time, minus 4, bring down the 7. This is just long division here. 4 goes into 17 4 times without going over. I'm going to minus 16, so I have a remainder of 1. So I to the 57th is the same thing as I to the 1st power, or I. And I can do that for any exponent of I. When we write our answers, I need you always, and if you're writing a complex number, your answer must always take this form. So you can't have an exponent higher than 1 on I. So if you leave I squared in your final answer, it's going to be marked wrong. Okay, so let's go ahead and get to some operations. I think these are pretty easy, personally, because it's literally the same exact thing as you would do if i's were x's, and then you just simplify afterwards. So I'm thinking of this as if I'm combining like terms, right? So the like terms are 3i and 6i. Add those together, 9i. Voila! The like terms are -5 and -10. Those are the real parts. I get -15. So if I were asked for this in the form a plus bi, and you were asked, like, what's a? Well, a is the real part, which is -15, and b is the imaginary part, which is the coefficient on I, which is 9. Not that I asked you for that. I just asked you to perform the operation, but that's just something My Open Math has you do on occasion. Okay, Number 2, let's treat this like a normal distribution problem. So I'm going to do 4i times 3i, that's minus 12i squared. Negative 4i times negative 1, that's plus 4i. Go ahead and combine like terms. 2i and 4i is 6i. And this is minus 12i squared, but we know that I squared should be written as negative 1. So this is 12 times negative 1. So this is 6i plus 12. Again, if you were asked for the real part A, that would be 12. The imaginary part B, that would be 6. B is just the coefficient on the imaginary part. You weren't asked for it. It wasn't required. Your answer was 6i plus 12. Okay. Final one here with multiplication. We get distribution. 3 times 4 is 12. I'm going to pause the video and then just get the answer real quick, and you can check and see if you're right. Go ahead and pause the video too. Okay, so distributing gives me 12 plus 2i minus 2i squared. Again, I'm not allowed to leave I squared in my answer, so I'm going to go ahead and write that as 12 plus 2i minus 2 times negative 1. And that's really plus 2, so this will be 14 plus 2i. All right, final answer, 14 plus 2i. Okay, the fun part is when we do division. So with division, the technicality here is the same. You can kind of think of division as the same way that you think about radicals. If you remember, you're not allowed to leave a radical in the denominator. So we have to undo the imaginary in the denominator. We can leave that imaginary number in the numerator. It's perfectly fine. We just can't leave it in the denominator. So if we look at this, we have to address what the complex conjugate is. The conjugate is the way that we're going to get rid of that imaginary number. Okay, so if I have a number that takes on the form a plus bi, the complex conjugate means take the opposite of the imaginary part. Okay, so the complex conjugate of a plus bi is a minus bi. So if I'm looking at 3 over 2i, I'm going to multiply the top and the bottom by the conjugate of the denominator. So in this case, the denominator is 2i. The conjugate of that is negative 2i. So I multiply both top and bottom by negative 2i. The top gives me negative 6i. The bottom gives me negative 4i squared. This simplifies to negative 6 over 4, and that simplifies to negative 3 halves I. So negative 3 halves I is your final answer. In number 5, the conjugate of 2 minus 3i is 2 plus 3i. So we're going to multiply by 2 plus 3i in both the numerator and the denominator. In the top, I multiply that out. It gives me 10i plus 15i squared. In the denominator, when you multiply this out, it's 4. Now, the cool part about this is you're going to notice 2 times 3i is positive 6i. Negative 3i times 2 is negative 6i. So that imaginary part will drop out. So I really just need to focus on multiplying the first numbers and the last numbers. So this will be 4, and then it'll be minus 3i times 3i is 9i squared. And so I end up with 10i in the top minus 15, because that's 15 times negative 1, and 4 plus 9, because that's negative 9 times negative 1. And so final answer, I get 10i minus 15 all over 13, and I'm done. Excuse me. Okay, one more. If I have 4 minus I times, actually, you guys can do that one on your own. I'm gonna go ahead and skip to something a little more fun. This is review 7 and 8. You should be able to do those completely without me. Number 1 is a review. We've done problems like that. Number 2 is not a review because we now are saying, hey, write a quadratic with these imaginary solutions. So just like with the radicals, right? We talked about this already. Imaginary numbers are always going to come in pairs. They're always going to come with their conjugate. So if x equals 4 plus I is a solution, so is 4 minus I. So I'm going to go ahead and write this out in factored form. So this is a times x minus the quantity 4 plus I times x minus the quantity 4 minus I. Multiplying that out, I'm not going to multiply the a out yet, but that gives me x squared. And then it's going to be negative 8x, right? Because it'll be negative x times negative 4 and negative 4 times x. So negative 8x. and then it'll be 4 times 4 is 16, and it'll be I times negative I, which is negative I squared, so it'll be plus 16 and minus I squared. And then last but not least, we end up simplifying this, so we get a times x squared minus 8x plus 17. 16 plus 1 is 17. I want to have a y-intercept of 34, so I ask myself, what does a need to be so that when I distribute, I will have a c term of 34, and a needs to be 2. So I can write this as 2 times x squared minus 8x plus 17. If I ask you for the answer in standard form, you have to distribute that 2, and voila. Okay, numbers 3 and 4 are complete review. 5 is also a review question. Okay, so that's it for the video. Go ahead and complete the rest of this worksheet, and answer key will be posted in Canvas.